Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest moving planet, The ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. MESSENGER really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, BepiColombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with one flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. BepiColombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows BepiColombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, BepiColombo would head off into the Sun. Now, once in orbit around Mercury, BepiColombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, one European, the MPO, Mercury Planetary Orbiter, and one Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. BepiColombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by BepiColombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. BepiColombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to BepiColombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby!
This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed a billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds, spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk with the central star in the middle. Almost all planets in our solar system move counterclockwise around the sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations showed that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere. A day on Uranus lasts just a little bit over 17 hours. That's how long it takes the planet to complete a single rotation on its axis. But its tilt is so pronounced that most of the time, either one or the other pole is pointed toward the sun. That's why the daytime length at the North Pole is almost half a year, and a year on Uranus is as long as 84 years. If you lived on Uranus closer to its North Pole, you'd be able to see the sun in the sky for 42 years. That would be the summer. After this, the sun would go down, and you'd have to live the next 42 years in the darkness. It'd be the winter on the planet. Neptune is the most distant and the smallest of the gas giants. The gravity on the planet is similar to the one we have on Earth, but you wouldn't be able to stand on Neptune's surface. It's gas, not solid land. Triton, the biggest of the planet's moons, orbits Neptune in a very unusual way. It moves backward compared to the rest of the planet's moons. Triton is also slowly spiraling inward toward Neptune. One day, billions of years from now, it's likely to get torn apart by the planet's gravitational forces and become just a ring around Neptune. This ring will continue being pulled inward until it eventually crashes into the planet. Pluto is a dwarf planet, and a year there lasts 248 Earth years. But even though it's not even a planet, Pluto still has several interesting things to offer, like floating mountains. Pluto's nitrogen glaciers carry countless isolated hills, each up to several miles across. They're likely to be fragments of water ice from the dwarf planet's surrounding uplands. Nitrogen ice is denser than water ice, so scientists think water ice hills float in a sea of frozen nitrogen, just like icebergs in the Arctic Ocean here on Earth.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the Sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here. but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. So, a planet a few times bigger than Earth, where actual diamonds fall from the sky like rain, it already sounds pretty sci-fi, but trust me, that's not even the strangest part of the story. You see, scientists recently pointed the James Webb Space Telescope toward this world with a name that looks like my driver's license, and found out that it ignores many rules. Most planets, just like Earth, circle normal stars like our Sun, but the Diamond Planet, let's call it like that, circles a pulsar. This world circles something far scarier than a normal star, a pulsar, a type of neutron star. Pulsars are born when the massive star collapses and a supernova goes boom and wipes out all nearby planets. And even if those planets don't stop existing immediately, radiation literally strips material off of the companion star over time. Bit by bit, the pulsar eats it alive, like a cosmic cannibalism. But the new mysterious object isn't a star, it's a planet. And planets shouldn't survive anywhere near that kind of radiation or evolve into something chemically bizarre. But anyway, the pulsar that the Diamond Planet lives next to spins insanely fast and fires beams of radiation like a cosmic lighthouse made of gamma rays. Normally, stars blind telescopes when scientists try to study nearby planets, but pulsars don't shine much in the infrared light, the kind the James Webb Space Telescope detects. So, astronomers could see the planet glowing while its deadly parent, the pulsar, stayed almost invisible. They noticed that its mass, radius, and temperature are pretty normal for a so-called hot Jupiter. That's one of the rarest types of exoplanets. But then, things got weird. Well, weirder. First off, not so many pulsars we know of host exoplanets. And none of those planets scientists have spotted so far are gas giants. Second, the Diamond Planet shape is pretty weird. Because it orbits its pulsar at a distance of just around 1 million miles, it's really affected by its gravity, and that's why it has its unusual lemon-like shape. But the weirdest thing is the planet's atmosphere, which contains huge amounts of helium and carbon molecules. That carbon is floating freely instead of bonding with oxygen or nitrogen, like it usually does. Under temperatures between about 1200 and 3700 degrees Fahrenheit, carbon shouldn't survive in that form at all. On almost every other world astrophysicists know of, it quickly links with other elements. But our weird planet just ignores that rule completely, and none of the well-studied exoplanets act like this. It looks like the pressure deep inside this diamond world squeezes carbon so hard that it turns into diamonds, and they constantly fall toward the core like glittering hailstones the size of mountains. Scientists still don't fully understand what's happening with this diamond world. They tried comparing it to something called a black widow system. It usually has to do with two objects locked in orbit, a dense pulsar and a smaller companion star, similar to our Sun but much brighter. The diamond planet shows overwhelming amounts of carbon, far more than physics tells us is possible. It doesn't look like it formed like a normal planet from leftover dust and gas, and it doesn't seem like it formed from a star that got stripped down by a pulsar. So, as of now, it doesn't fit into any known formation scenarios. The pulsar may have erased a former companion star so completely that only an ultra-dense carbon core survived. Another idea is that extreme radiation reshaped an existing planet over millions or billions of years. Meanwhile, while scientists are solving this mystery, let's visit Uranus, where it also rains diamonds. Deep inside this ice giant, temperatures climb above 12,000 degrees Fahrenheit according to mathematical models, and pressure rises millions of times higher than Earth's atmosphere. Methane gets crushed until its molecules snap apart. The freed carbon atoms cling together, form crystal structures, and grow into diamonds. Those diamonds sink deeper, melt in hotter layers, rise again, and repeat the cycle endlessly. And not only that, the James Webb Telescope showed that Uranus's magnetic field tilts about 60 degrees off balance, which means the planet's invisible magnetic shield sits crooked compared to its rotation. On Earth, auroras stay near the poles, but Uranus spreads glowing auroras across huge regions of its atmosphere. Webb watched the planet spin for 15 hours, which is almost a full Uranian day, and captured massive energy flows moving through the upper atmosphere like glowing weather systems powered from deep inside the planet itself. All this means that ice giants distribute heat in ways we barely understand. Uranus almost rolls sideways as it orbits the Sun, and that strange orientation seems to twist how charged particles move through its atmosphere. Instead of neat polar light shows like ours, Uranus creates wandering auroras, also pronounced wandering auroras, that stretch across the planet like cosmic neon storms. Studying them can help researchers understand magnetic fields. It's a pretty big deal because they act like planetary force fields that protect atmospheres from space radiation. At the same time, another mysterious world has its own pretty weird weather system. I'm talking about Titan, Saturn's largest moon. Titan doesn't use water for rain or lakes. It uses methane, the same gas we burn for fuel on Earth. Scientists discovered that Titan's seas actually shape its local weather, just like the Great Lakes influence climates in North America. Liquid methane evaporates, rises, cools, and falls again as mist or rain. Warm air lifts upwards, while cool air rushes in behind it and forms convection cells, which are giant looping currents of moving air that drive storms. And not just regular storms we're used to. No! Titan has lake breezes, fog banks, and seasonal weather cycles that run on hydrocarbons instead of water. Titan's big brother, Saturn, doesn't just have weather. It throws atmospheric tantrums on a scale that makes Earth storms look like brief summer rain. When NASA's Cassini spacecraft orbited Saturn between 2004 and 2017, its instruments picked up lightning flashes so powerful they could shine even in broad daylight. On Earth, lightning already releases temperatures hotter than the surface of the Sun for a split second. On Saturn, some bolts carry 10,000 times more power than lightning here. Cassini even detected radio signals from these storms, which means researchers could literally listen to thunder rolling across another world. Some of these storms expand more than 190,000 miles wide, large enough to circle nearly the entire planet. Then there's Saturn's famous North Pole hexagon, a perfectly shaped six-sided jet stream spinning non-stop for at least 40 years since spacecraft first noticed it. Wind streams racing around the pole naturally lock into this geometric pattern. That hexagon stretches hundreds of miles deep into Saturn's atmosphere. Now let's hop onto Venus, where the climate spirals completely out of control. At its south pole, a spacecraft saw a massive double-eyed vortex, roughly the size of Europe, spinning endlessly in thick yellow clouds. Unlike Earth, where the atmosphere mostly moves together with the planet, Venus has something called superrotation. Its atmosphere races around the planet about 60 times faster than the surface below. Winds roar at speeds near 250 miles per hour. The surface temperature there is around 870 degrees Fahrenheit, hot enough to melt lead, zinc, and many spacecraft components. It's so hot because sunlight enters easily, but dense carbon dioxide traps outgoing heat so efficiently that cooling never happens. Even rain behaves cruelly there. Sulfuric acid forms high in the clouds and falls downward, but intense heat evaporates the droplets before they ever reach the ground, and rain just disappears mid-air. Well, our final stop of the day is Neptune. It receives only a tiny fraction of the sunlight Earth gets, but somehow drives jet streams exceeding 1,300 miles per hour, twice faster than the speed of sound. Heat must be rising from its interior to fuel such speeds. When Voyager 2 flew past in 1989, it spotted the Great Dark Spot, a storm system roughly the size of Earth itself. Neptune's storms appear and disappear within years, and behave like living systems that constantly evolve. Some of its storms drift toward the equator and then suddenly reverse direction. That never happens on Earth. So Neptune is another reminder that weather in space doesn't always follow familiar rules. Sometimes, physics builds systems so extreme that scientists can't explain them even after decades of observation. Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call the newly discovered eighth planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth. And if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. You wouldn't be able to land on this planet. Its mantle, made up of water, ammonium, and methane ice, is the closest thing Neptune has to a surface. But even down there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Well, let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. That explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course there are theories because they're scientists. Some experts believe there is something fierce inside the blue planet that causes it to generate more heat than it receives. It might be the reason for Neptune's huge differences in temperatures, from minus 260 degrees Fahrenheit at the planet's rigid cloud tops to more than 12,000 degrees at the core of the ice giant. So, you're going to want to dress in layers. Now, such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,200 miles per hour. For comparison, the most powerful winds on Earth move at a speed of 250 miles per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 600 miles thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye on Neptune. But, disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that, from time to time, Neptune's surface gets dotted with such spots. These bizarre discolorations have been linked to high-pressure areas, coming and going over the course of a few years. But no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Now, despite assumptions, astronomers once thought Neptune was a boring, featureless world. The ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a fun little experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why, after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red-hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core made up of iron and other metals. Okay, let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the Moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear to be 15 times larger than the Sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why, instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a great risk of Earth colliding with this space body. Uh-oh. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would be 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, that sounds unsettling, so let Neptune remain where it is now. I'm okay with a good old moon. Now we're done with the experiments, but hear me out. Beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system. But not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it. But it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, Scientists thought this moon was nothing more than a block of ice, but now they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis, and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of 2 parallel universes. Imagine that universes are giant bubbles, and one day, two of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe. We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own, and our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. the planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super habitable. So some scientists think that Earth is a good place for life, but not the best. Super habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.
So planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth, with no need to invent something. There could even be a combination of 2 elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, 2 gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If 2 cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic. unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up. Like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago, too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers, too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant, maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
So check this out. The most powerful telescope we could ever use already exists. It doesn't need a lens or a giant glass mirror. This telescope is 4.5 billion years old, 109 times wider than Earth, and has a diameter of 864,000 miles. Yep, the Sun itself might become our telescope, and it's totally doable. Now, the Sun isn't a lens or a mirror like in a regular telescope, but it's supermassive, and according to Einstein, heavy stuff like that can bend space and time around it. When light passes close to the Sun, our star's gravity bends it, and instead of traveling in a straight line, the light curves slightly as it goes by. Imagine a heavy bowling ball sitting on a stretched sheet. The sheet dips around it. If you roll a marble nearby, it won't go straight. It will curve toward the dip. The Sun does the same thing to light. Its huge gravity slightly bends passing light inward. And that bent light ends up gathering at a distant point, which is called a focal point. Astronomers already use this trick, called gravitational lensing, to watch the farthest galaxies in the universe. When light from a very distant galaxy passes near a huge cluster of galaxies, the cluster's gravity bends and kind of boosts that light. It works like a natural cosmic magnifying glass and makes the faraway galaxy look brighter and larger. This way, we can see much farther than we normally could. Now picture this. Light is coming from a planet or star billions of miles away and grazes the Sun as it passes by. Thanks to gravity, the Sun bends it. Now all we have to do is put a sensor at that focal point and catch the light. It sounds simple, but there's a problem, like always. That focal point is about 542 astronomical units from the Sun. To put that in human terms, that's 542 times the distance from Earth to the Sun, 13 times farther than Pluto, and more than 3 times farther than Voyager 1, the farthest human-made object has been traveling through space since 1977. In other words, sending a spacecraft that far, keeping it alive, and getting it to do its job isn't a weekend road trip. Plus, the focal point isn't a tiny dot. It's more like a huge lighted patch tens of miles across. If you park your spacecraft in one spot, you'll only see a tiny slice. And if you want the whole picture, you'll have to move it across all that gigantic focal area, scanning bit by bit. But it's even more difficult than that. The target you're trying to image, another planet or a distant star, isn't standing still. By the time your spacecraft reaches the focal area, it can't just aim anywhere and hope for the best. You have to predict exactly where the target will be, or your telescope will be staring at empty space. It means that even though the Sun's gravity provides us with a cool natural lens, using it is super complicated. You'll have to deal with huge distances, moving targets, and a focal area bigger than the largest cities on Earth. But what if we managed to pull it off? Then we'd be able to see things in the universe with a clarity no other telescope has ever matched. Now, the crazy part here is that this plan isn't some sci-fi nonsense. We'd have to send a spacecraft, or maybe a whole swarm of them, 3 times farther than Voyager. But after all, that's not hopping to another star system. This is still inside our solar system. It's just really far. One idea experts have entertained for decades is the Super Voyager approach. It goes like this. You just fling a probe out there, let it zoom through the Sun's focal point, collect whatever light it can, and beam it back. Great! But you only get a tiny snapshot of a minuscule patch of your target. It's not even a full-blown image. It's like looking at a single pixel of the Mona Lisa and claiming you've seen the entire masterpiece. What we really need is a spacecraft that can hang out there, move around, and scan the whole focal area, slowly mapping a target in precise detail. The latest proposals don't even involve one big spacecraft. They suggest a swarm of tiny spacecraft all working together to create a full picture. They could be like a team of painters working on a huge wall. But that's not easy. Tiny spacecraft still need instruments, power, and fuel. This will make them bigger and heavier. It kind of defeats the whole point of having tiny ships. Then, how about solar sails? The idea is really cool. We could launch the swarm from Earth, let them travel toward the Sun, unfurl their sails, and let solar radiation pressure, which is basically sunlight, push them like cosmic sailboats. They would accelerate insanely fast and reach 542 AU in a few decades, which is pretty long, but not impossible. After arriving at their destination, they carefully move in formation across the huge focal plane, each one collecting its own slice of light. Then, they'd beam all that data back to Earth, helping us build the whole picture using the Sun as the most epic telescope ever. What could we get with this crazy setup? Well, point it at Proxima b, the nearest exoplanet, and you could see an almost 1-mile resolution. Compare that to the next-gen space telescopes, where the whole planet is just a few blurry pixels. You could see mountains, oceans, maybe even continents of any planet within 100 light-years. Imagine everything else we could observe. No wonder that a lot of research has gone into this, but there's still a huge gap in our capabilities. Right now, we don't have solar sails that are powerful and efficient enough, and we certainly don't have swarms of spacecraft that can coordinate and operate together at that distance. All the current proposals are impossible at this moment. They're just beyond today's technology. But with the right breakthroughs, though, it's entirely feasible. After all, we already have some incredibly powerful telescopes that provide us with breathtaking views of the universe. Like the James Webb Space Telescope. Such machines are true engineering monsters, billions of dollars, decades of work, and giant mirrors. For example, James Webb's mirror is 21 feet across and can resolve details about 600 times sharper than the human eye. At that resolution, it could read the pattern on a coin from 25 miles away, or see the design on a soccer ball sitting over 340 miles away. Or take the Hubble Space Telescope. It detected elements from the early universe, proved that supermassive black holes existed, and showed black holes at the heart of galaxies. It captured the first collision between astronomical objects, spotted oxygen in a moon's atmosphere, and even took the first image of a star's surface other than the Sun. It gave us the first visual evidence of planetary building blocks, first exoplanet atmospheres, and even found organic molecules in other worlds. It photographed asteroids with tails, captured asteroids breaking apart, and detected water vapor plumes on Europa, one of Jupiter's largest moons. Hubble saw the first predicted supernova, the farthest galaxy and star ever imaged at the time, and water vapor on an exoplanet in the habitable zone. It even snapped the first ultraviolet image of a forming exoplanet and spotted a possible moon orbiting an exoplanet. Then there's the Event Horizon Telescope, which isn't just one telescope, it's a global network. By syncing instruments around the world, it gave us mind-blowing images of gas swirling around black holes. Its resolution is 20 microarcseconds, which means it could spot an orange on the moon. And still, if we wanted to go even bigger, we'd need massive dishes or swarms of telescopes flying through space, which would be like building a telescope the size of a small country. That's why the Sun as a telescope is such a great idea. It already has the mass, the bending power, and it's sitting there for free. We just need a camera in the right place to catch all that light.
Frozen plains, icy mountains with their snow-capped tops glistening in the sun, valleys, craters, eternal freezing winter.
Wow. Hello there, Pluto. At first sight, it looks like a paradise for adventurers who love skiing, snowboarding, and all the other fun things you can do in snowy winter wonderlands. But the snow there is not like what you can find on the mountains of Earth. On Pluto, the mountain peaks are covered with frozen methane, while down here they're made of frozen water crystals. Because of its specific chemical composition, the snow on Pluto is red. The mountains themselves are very different too. They reach heights of up to almost 10,000 feet. But they're not rocky like ours, looking more like huge blocks of ice. Such a landscape cannot be found anywhere else in our solar system. But you'll need to pack some layers if you want to come visit. The average temperature there ranges from minus 375 to minus 400 degrees. When taking a look at it from a distance, you can see it has some kind of big, heart-shaped thing on its surface, called the Tombaugh Regio. That's actually a vast plain the size of Oklahoma, or Texas, that's covered in nitrogen ice. Scientists discovered this heart actually makes the winds of the planet blow. Craters are also big here, sometimes more than 160 miles in diameter, and some of them show signs of filling and erosion. Erosion is when land is worn away by natural forces such as wind, water, and ice. It's the same process that formed many interesting things that you can see on the surface of the Earth, like valleys, coastlines, peaks, or mountains. The fact that some craters are there because of erosion tells us that tectonic forces must be slowly changing the surface of Pluto. 1/3 of its surface is water, but not the kind that we like to drink, more like a really hard frozen ice. Water is vital for the evolution of life, but not water that's this cold, so it's unlikely that any life has formed here. At least for now. But how do we know all these things about Pluto? Well, here's the basics. Astronomers discovered Pluto in 1930, and just like with plenty other moons and planets, they named it after a figure from Roman mythology, the ruler of the underworld. Pluto was considered the 9th planet of our planetary system until 2006, after which it was recategorized as a dwarf planet. Despite its recent demotion, it is still the largest and the oldest known object in this region of the Kuiper Belt, an outer shell full of other dwarf planets and icy bodies. New Horizons. That was the name of the very first space probe that astronauts sent to have a look at Pluto in 2006. It reached a distance of up to 7,800 miles. While there, it took some important photographs and collected lots of important information and discovered some of the mysterious cosmic oddities found on the surface of Pluto. One interesting thing about this former planet is that it sometimes has an atmosphere and sometimes not. It has an oval-shaped orbit, which means, unlike most other planets, it doesn't travel around the sun in almost perfect circles. As a matter of fact, the sun is nowhere near the center of its orbit. When its orbit takes Pluto closer to the sun, the extra heat warms up a kind of thin atmosphere made primarily from nitrogen, an element our Earth also has in its atmosphere. Right after it's created, it gradually escapes Pluto's weak gravity. When the dwarf planet moves away from the sun, the atmosphere freezes and goes back to its solid state, falling back down to the surface of Pluto as nitrogen snowflakes. Pluto's interior is supposedly warmer than its surface. Some believe there's even an ocean deep underground. Despite being the largest known body in the Kuiper Belt, Pluto is still pretty small. It is smaller than the Earth's moon, around half the width of the United States. It has 5 spinning moons of its own, the biggest one half the size of Pluto itself. Our days last 24 hours, while one day on Pluto lasts 153. Earth needs 365 days to orbit the sun, while a year on Pluto lasts 248 Earth years. So, no birthdays there at all. It sits 3.6 billion miles from the sun, which is 40 times the distance of the Earth stands. If you were standing there, on Pluto, watching the night sky, you'd see the sun as just one small distant star, indistinguishable from the rest. Since Pluto has been demoted, Neptune is now the most distant planet of our solar system. It's also pretty fascinating. It's actually a huge ball of ice and gas. Yes, it's the densest gas giant in our solar system, but you still couldn't stand or walk on its surface. You would simply sink in. But if you could stand, you'd notice that the gravity force is similar to what we have on Earth. Despite its impressive size, though, Neptune is not visible to the naked eye from here. It's the windiest and coldest planet. And one year there lasts 165 Earth years. Still no birthdays. It takes more than 4 hours for the light coming from the sun to reach Neptune's surface. Our next gas giant is Uranus. 1 year on Uranus adds 84 Earth years, so you can maybe get one birthday in there, but you better make it count. Just like Neptune, Uranus can't be seen without the help of advanced technology. The rest of the 6 planets can. But you can still see all 8 of them with binoculars or a smaller telescope. Now, pause the video, see if you can make your astronomy teacher proud, and try to remember which planet comes next in order from furthest to closest to the Sun. You got it? That's right, it's Saturn. A+. Saturn is the 2nd biggest planet of our solar system, right behind Jupiter. And another gas giant where you'd sink in if you tried to walk on it. It's so gassy, you could put it in a lake and it would float. They call it the jewel of the solar system because it has a big ring system that kind of looks like a crown. Its rings are made up of dust, pieces of ice, and rock. Some of those pieces are as tiny as a grain of sand, while others are bigger than tall buildings. Next on the list, and completing our gas giant quartet, is Jupiter. Scientists call it a failed star since it's mostly made up of helium and hydrogen, just like the main star in our solar system, the Sun. But Jupiter doesn't have a mass big enough to start the chemical processes that turn it into a star. However, it is still the 5th brightest object in the solar system, right behind Mars. You probably have seen it when stargazing sometime, you just had no idea what it was. Okay, picture all the other planets combined and double their mass. That's a lot of mass, but Jupiter still has more mass than that. It's also the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Our day lasts 24 hours. Imagine how it would look like to squeeze sleep, work, family, friends, hobbies, movies, all that in just 10 hours. I guess I'd have to sleep once every other day if I lived there. Now, picture this. Magnificent tall mountains, giant dust storms, volcanoes, deep valleys, craters. Mars. That red jewel scientists keep talking about being a potential new home for us. There were even some small meteorite pieces found on Earth that scientists realized were ejected from Mars. That's how close we are. If you love sunsets, you would definitely enjoy the ones here because they're incredibly blue, while the daytime sky is pinkish red. But when on Mars, you'd only see the sun at half its size compared to what we see on Earth. And of course, there's Earth itself. Seas, mountains, valleys, waterfalls, and of course, life. For 4.5 billion years, Earth has been home to so many different kinds of organisms that have lived, died, and lived again. And even though we know so much about our homeland, there's always something new to discover each and every day. The next planet, Venus, is the champion of superlatives. The hottest surface, the closest planet to the Earth, the biggest number of volcanoes, 1,600. If you compare it to other planets to our solar system, the brightest planet, with reflective clouds that make it so shiny you can see it from the surface of Earth. Oh yeah, and the slowest spinning body as well. It takes 243 Earth days for Venus to make just one single turn. You could literally walk faster than the planet's rotational speed. Venus also goes in the opposite direction of Earth, so sunsets there are set in the east, sunrises in the west. And last, but not least, Mercury. It doesn't have any moons or rings, and it's the smallest planet in our solar system. A year there lasts only 88 days. So get ready to expand that birthday budget. Mercury is the planet the closest to the sun, but not the hottest. Venus took that title. Mercury is not the hottest because there's no atmosphere to trap the sun's heat there. But it does have wrinkles. Only 1/2 of Mercury's surface faces the sun at any given time, meaning there's an incredible difference in the temperature on either side, and of course these sides switch as the planet rotates. The iron core of this planet has cooled and contracted over millions of years due to the rapid change in heat, which is why wrinkles have appeared on its surface. Well, that's a brief tour of all the planets of our solar system. And one dwarf planet. Sorry, Pluto. Thanks for watching.
2 billion people will be able to watch an asteroid the size of a skyscraper slide past Earth closer than many satellites. It's scheduled to happen in April 2029. Now, an asteroid of this size comes this close to our planet just once in 7,500 years, and it has to do with a strange interstellar visitor called 3I Atlas that recently shook scientific certainty. Here's how. The Atlas Survey System, a nickname for Asteroid Terrestrial Impact Last Alert System, that's a mouthful, well, it scans the sky every night looking for objects that might threaten Earth. When it first flagged 3I Atlas in 2025, it appeared as a faint smudge in telescope data, the kind of thing astronomers almost ignore because the sky is full of harmless junk. Then, scientists calculated its speed and direction and realized something was off. It wasn't bound to the sun like most comets and asteroids. Space objects usually follow clean curves dictated by gravity and sunlight. Sunlight heats a comet, ice turns to gas escapes – hey, I know all about that – and that tiny push slightly alters its path, like a slow leak nudging a balloon. 3I Atlas didn't just nudge, it lurched. It accelerated in ways that didn't line up neatly with heating models. It was moving too fast, on a path that screamed interstellar origin, which means it came from another star system entirely. It shifted direction slightly but persistently. That kind of motion means our models weren't telling the full story. Researchers figured out the object's structure must be unusual, like a fragile pile of rubble venting gas from unexpected pockets. It was also possible that its surface chemistry reacted differently to sunlight than anything we've seen before. And maybe it meant that tiny forces scientists usually ignored actually matter more than they thought. NASA and the ESA both emphasized that this thing, I'll just call it 3I, wasn't an extraterrestrial spacecraft, unlike what the internet crowd supposed. It sent no signals, there was no propulsion or artificial materials involved, just ice and dust. Nobody feared 3I would hit Earth, that part was clear, but they worried they wouldn't be able to predict its behavior. Space safety depends on knowing where things will be tomorrow, next year, and decades from now. 3I showed that even small bodies can act like trick coins instead of clean equations. And this knowledge is important to predict the behavior of our today's featured thingamabob, the asteroid Apophis. Got its nickname after the Egyptian deity of chaos, which is a bit worrying already. This bad boy will pass less than 20,000 miles away from Earth. Sounds like it's no biggie, but that is closer to our planet than the satellites that handle weather forecasting and global communications. Around 2 billion people living all over Africa and in Western Europe will be able to see it with their unaided eyes. Earth's gravity at that distance won't just wave hello, it will grab Apophis hard enough to potentially change its spin, crack its surface, or shift its internal structure. Scientists call these tidal forces. Think of it like squeezing a stress ball. You don't break it, but you don't leave it unchanged either. Now, before scientists studied 3I Atlas in detail, Apophis felt manageable, and its orbit looked pretty stable. Its flyby was supposed to be a controlled event. But when they learned more about 3I Atlas, scientists started framing 2029 differently, not as danger, but as a stress test. If Earth's gravity nudges Apophis even slightly, models need to capture that in real time. That's why the European and Japanese space agencies developed the Ramses mission. It's a spacecraft packed with instruments and a Swiss-built high-resolution camera that will observe Apophis up close during the encounter. They want to see ruptures forming, dust shifting, spin rates changing. It's basically the asteroid equivalent of a human heart monitor. Now, the good news is that Apophis won't hit Earth in 2029, and scientists say that clearly. But safety depends on predictability, and predictability took a hit when 3I Atlas misbehaved. So the scientists are now watching Apophis closely to test their assumptions in the safest way possible, with a known object, a known time, and every telescope pointed straight at it. Of course, they didn't take their eyes off 3I Atlas either. One of NASA's newest spacecraft, Europa Clipper, is cruising toward Jupiter right now, with a long trip ahead of it. On the way, scientists realized they had a perfect chance to point their instruments at this interstellar comet. From about 102 million miles away, Europa Clipper turned its camera and watched 3I Atlas drift by. What it captured isn't something your eyes could ever see. The image came from an ultraviolet instrument designed to study Jupiter's icy moons, not comets, and it observed 3I Atlas for 7 straight hours. Ultraviolet light reveals gases and elements that stay completely invisible in normal photos. It's a way for scientists to see the comet's chemistry in action instead of just its shape. That glowing cloud around the comet, called the coma, tells us what's escaping from the ice as sunlight hits it. By studying how those gases spread and move, scientists can learn what 3I Atlas is made of and how active it really is. Now, so far, scientists have had a chance to find some pretty unusual things about its chemistry. Radio telescopes in the Atacama Desert locked onto the comet and picked up clear signals from methanol and hydrogen cyanide. These two molecules that sound boring and somewhat deadly until you realize they sit right at the entrance ramp to life chemistry. These weren't tiny traces either. 3I Atlas pumped out methanol at levels that jumped sharply as it approached the sun. They spiked right where water ice starts to vaporize. Compared to most comets humans have ever measured, this thing came loaded. Its methanol to hydrogen cyanide ratio landed among the most enriched values ever seen. This doesn't mean that 3I Atlas carries life, or bacteria, or anything even remotely alive. But these molecules matter because chemistry doesn't jump straight from rock to organism. Life, at least the kind we understand, builds itself step by step. Hydrogen cyanide plays a key role in forming amino acids, the Lego bricks of proteins. Methanol acts like a chemical multi-tool that helps assemble more complex molecules, like sugars and the precursors to DNA and RNA. On 3I Atlas, methanol made up about 8% of its vapor, and that's roughly 4 times what we usually see in solar system comets. Another cool part is where these ingredients for life came from. 3I Atlas formed around another star inside another planetary system, under conditions we can only guess at. And yet, it shows up carrying the same basic toolkit that life on Earth relies on. That lines up with an old idea scientists have kicked around for decades. Comets and asteroids might act like delivery trucks, scattering water and organic molecules across young planets. Earth may not have invented its chemistry from scratch. It may have inherited it. Now, before 3I Atlas, we had only confirmed 2 interstellar visitors, Oumuamua in 2017 and 2I Borisov in 2019. Oumuamua freaked everyone out because it didn't look like a normal comet at all. It had no obvious tail, showed weird acceleration, and was of a cigar-like shape. So the internet went wild with crazy extraterrestrial theories. Borisov felt like a relief by comparison. It behaved exactly how a comet should, growing a coma, releasing gas, and cruising through the solar system without drama. Some people feared Borisov could collide with Earth or disrupt planetary orbits. But it flew by smoothly, boring even, like a guest who followed every house rule. Borisov reassured scientists that interstellar objects could be predictable. 3I Atlas shattered that calm and showed us they could quietly undermine confidence without causing harm. Apophis now stands as the ultimate test run. Scientists already know it won't hurt us, but then again, the examples of interstellar visitors show how little we actually know about them. It indicates that space has its own, mostly unknown rules, is highly hostile to human life, and it's not very polite either. It doesn't announce surprises in advance, and the better we know about it, the better we can be prepared for these surprises.
We've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler 22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler 22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler 22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler 22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler 22b. That would be awkward if it turns out to be a gas planet, or something like that. Our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets, Mercury, Venus, Earth, and Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies. Maybe even a new planet! Models scientists made say that our solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is, if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet left in an orbit similar to the ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFBD SIR 2149. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees Fahrenheit. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light-years away from our planet. Our galaxy, the Milky Way, is 100,000 light-years wide, so that's relatively close. The lonely traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit. Or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, there's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J1407b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our Sun. Super Saturn is 434 light-years away from Earth, in the constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ1214b, a steamy world, bigger than Earth and smaller than Uranus, 40 light-years away from us, in the constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees Fahrenheit, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet 30 light-years away from our planet in the constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our Sun, at a distance 15 times closer than Mercury is to the Sun. When we typically think of ice, we picture a frozen cube. But this planet has an icy surface, even though the temperature there is 980 degrees Fahrenheit. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather and pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees Fahrenheit. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900 degrees Fahrenheit. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and it completes its orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy. The winds blow at up to 5,400 miles per hour, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230 miles per hour. And it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen for us. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ504b, far away from us, in the Virgo constellation. 4 times more massive than Jupiter, it's a newly formed exoplanet, around 160 million years old. By comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta.
Soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangaea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking, and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the ring of fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear, which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing. It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about. 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please. Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation, So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk, nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia, in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the Sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life. Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the Sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments.